5.4, the first derivative test. The first derivative test is to find relative min or max values. Okay, first derivative test involves the first derivative. So if f prime changes from positive to negative, so think of f prime, the slope of f changes from positive to negative, then there's a relative maximum or a local maximum at x equals a. If f prime changes from negative to positive, so the slope changes from negative to positive at x equals a, then there's a local minimum or a relative minimum at x equals a. Okay, so for the first derivative test, we're going to find the critical points. We're going to create a number line with the critical points, test the intervals to determine whether f prime is positive or negative, and then determine at what x values there are minimum or maximum values. Okay, so example 1, use the first derivative test to find the x values of any relative extrema. So first, find the critical points. To find the critical points, first derivative. So f prime of x equals 3x squared minus 6x minus 9. Critical points, we set it equal to 0 or figure out where this is undefined. This is defined everywhere, so we're going to do equal to 0. And I don't like the 3, so let's factor out the 3 or divide it. I set it equal to 0. So I get x equals 3 and x equals negative 1. What did the question ask? They asked for the x values of any relative extrema. So they want to know whether these are relative minimums or maximums, in addition to knowing the x values. Okay, these, I should check that they are defined in the original function. They are, because this is a polynomial function. So I'm going to make a number line, little one over here. I'm going to put my two critical numbers on here, which are negative 1 and 3. Okay, and then I want to check the signs of f prime. So I'm checking this in the f prime function. Okay, I'm going to plug in a number lower than negative 1, between negative 1 and 3, and higher than 3. I'm going to start with the easiest interval, which for me is between negative 1 and 3. So I'm going to plug in 0, because that's an easy number. You can plug it in this or this. I guess if it's 0, I could plug it in here. 0 minus 9 is negative. So between negative 1 and 3, f prime is negative. Okay, let's plug in a number higher than 3, and I'm going in an order that's easy for me. So maybe like 5. Okay, I can plug 5 in the original function. I'm going to plug it in the factored function. If I plug it in the factored function, this is positive 3 times 5 minus 3 is positive. 5 plus 1 is positive. So if I do 3 times positive, I'm going to get a positive value. And I don't need the actual value. I just need to know if it's positive or negative. Okay, let's plug in a number lower than negative 1. How about negative 2? Again, I can plug it in here. I'm going to plug it in the factored because it's easier. Okay, if I plug in negative 2, I have 3 times negative 2 minus 3 is negative. Negative 2 plus 1 is negative. So 3 times negative is also going to give me a positive value. Okay, now I'm going to consider at negative 1 and 3 whether these are relative minimum or maximum values. So at negative 1, f prime is changing from positive to negative. So there's going to be a relative maximum at x equals negative 1 because f prime changes from positive to negative, and x equals 3, f prime changes from negative to positive. So there's a relative minimum at x equals 3. It only asks me for the x values of the relative extrema. So this is the locations of the maximum and minimum. Okay, example 2, find the relative minimum maximum of g of x. Okay, this one I'm just going to note, it says find the relative minimum maximum. They want the actual value, not just the x values. Okay, but I'm going to start it the same way. I need the critical point, so let's do g prime of x. Okay, to find the critical points, we're going to set this equal to 0. Okay, so there's only one critical point. It's at x equals 3. Let's determine if this critical point represents a relative maximum or minimum or neither. So on my number line, I'm only going to put a 3. I'm going to try a number lower and higher than it, and I'm testing this in g prime to see whether g prime is positive or negative. So pick any number lower than 3. I'm going to use 0 because it's easy. And if I plug it in, 4 times 0 is 0, minus 12, this is negative. If I try a number higher than 3, how about 4? 4 times 4 is 16, minus 12 is positive. Okay, so this tells me that there is going to be, is changing from negative to positive. So x equals 3 represents a relative minimum. They want the actual value at 3 though. So I need to plug 3 in the original function to figure out what g of 3 is. And I'm plugging it in the original function to figure out the actual value. What is that? 2 times 9, 18 minus 36 is negative 18. Okay, now I'm going to answer the question. Find the relative, in this case it's a minimum because we determined that. So there's a relative minimum. The value is negative 18 and that occurs at x equals 3. Okay, those were kind of the level 1 questions. Let's skip to the harder level questions. So same, use the first derivative test to find the x values of any relative extrema. So I'm going to find the critical numbers and then determine which ones are relative maximum minimums. I need the derivative first. Okay, so I'm going to bring down the 2/3. I'm going to lower this to negative 1/3 and then chain rule times 2x. I think I'm going to rewrite this to make it easier for myself. So 2 times 2x, that's going to be a 4x. At the bottom, I've got a 3, and then 1/3 is the third root of x squared minus 4, although you could leave it as x squared minus 4 to the 1/3 if that makes it easier for you to solve. Okay, let me see. Let's set this equal to 0 and see what we get. Okay, if I set it equal to 0 and I multiply the denominator, this is times this goes to 0. So I get 4x equals 0. So x equals 0 is one of my critical points. Because there's a variable at the bottom, f prime x could also be undefined. So let's determine when f prime does not exist. That would be when the bottom equals 0. Okay, if I divide by 3, it's still 0. If I raise it to the third, it's still 0. So we're going to get to x squared minus 4 equals 0. And then when I solve that, I get x equals positive negative 2. Okay, let's just check the domain on the original function. This is a polynomial. I'm squaring it, which is fine, and then I'm doing a third root. You can third root positives and negatives, so there's no domain restriction. So all my points should be valid for better or worse. So I'm going to make a number line. I'm going to include 0, 2, and negative 2, and I'm going to put them in order. And since I'm doing the first derivative test, I am testing these in the first derivative, which is f prime. And I only care whether it's positive or negative. So keep that in mind when you're plugging in. Okay, let's see. What do I think is going to be the easiest thing to plug in? Let me go between 0 and 2. I'm going to plug in 1. If I plug 1 in, I'm going to plug it in here. If I plug in 1, the top is going to be 4 times 1, which is positive. Okay, on the bottom, this is positive. If I plug in 1, 1 squared, 1 minus 4 is negative 3. If I cube root negative 3, I get a negative. So positive divided by negative, this is going to be a negative. Let's plug a number higher than 2. How about 3? Okay, if I plug in 3, 4 times 3 is positive. If I plug in 3, 3 squared is 9, 9 minus 4 is positive, and if I cube root a positive, I get a positive. So positive over positive is positive. Okay, let's go backwards. Between negative 2 and 0, let's plug in negative 1. If I plug in negative 1 at the top, I get negative 4. If I plug in negative 1 at the bottom, negative 1 squared is 1 minus 4 is negative 3. I cube root negative 3, I get a negative. So negative divided by negative is a positive. And let me plug in negative 3 maybe. 4 times negative 3 is negative 12. If I plug in negative 3 squared is 9. 9 minus 4 is positive. If I cube root a positive, I get a positive. So this is negative. Okay. X value of any extrema. So let's determine which of these are relative minimum or maximum. So at negative 2, f prime changes from negative to positive to negative to positive. So there's a relative minimum at x equals -2 and at x equals 2, and it's because f prime changes from negative to positive. There's a relative maximum at x equals 0, and the reason would be because f prime changes from positive to negative. Okay, last example, example 4. Find the values of any relative minima or maxima of h of x equals x squared over 4 minus x. Remember, minima and maxima is the plural for minimum and maximum, so just minimum and max. Okay, first thing, find the critical numbers. So I need the first derivative. Can I make this better? Nope, I'm going to use the quotient rule. So low d high minus high d low, square the bottom, and away we go. Let's simplify this. 8x minus 2x squared plus x squared. Okay, so h prime of x equals 8x minus x squared over the quantity 4 minus x squared. Okay, if we set this equal to 0, okay, if I set it equal to 0, the denominator is going to go away anyways. So I'm really just setting the top equal to 0. Let me take out the x. So I get x equals 0 and I get x equals 8. Let me check. Is there any restriction on the original function? The only domain restriction I see on the original function is that x can't be 4. Okay, let's try the next one. Let's see when h prime does not exist. H prime does not exist when the bottom is equal to 0. So I get 4 minus x equals 0. So x equals 4. Does that work in the original function? No, because if I plug in 4, the original function has an undefined value, probably an asymptote. Okay, so there's only 2 critical numbers, but I had to check that does not exist because that might have been other critical numbers. 0, 8. Okay, I need to figure out which one's the relative min and max, and then I still need to figure out their actual values. I'm checking in h prime to see if h prime changes signs. So if I plug in, I'm going to pick x as 1. I just do the easiest interval first. If I plug in 1, 8 minus 1 is positive. 4 minus 1 is positive, squared is positive. Okay, let's try higher. How about 10? 80 minus 100 is negative. 4 minus 10 is negative, but then I squared it, goes to positive. So negative divided by positive is negative. Let's plug in negative 1. Negative 8 minus 1, negative 9. 4 minus 9, well, this is squared, so it's positive no matter what. So negative here. So what does this mean? It means there is a relative minimum at 0, a relative maximum at 8. Since they want the values of the relative minimum or maximum, I need the actual y values. Okay, so let's plug 0 and 8 into the original functions. So if I do h of 0, I get 0 squared over 4 minus 0, which is 0. And let me do h of 8, which is 8 squared, 64 over 4 minus 8. 64 divided by negative 4 is negative 16. Okay, and now I'm going to write my answer. There is a relative minimum of 0 at x equals 0. There is a relative maximum of negative 16 at x equals 8. Okay, and then this is my answer. And then remember, this is the actual value. If they ask for the actual relative minimum, maximum, or value, they want the y value. Okay, and these, just of note, the relative maximum value is lower than the relative minimum, and that's because it's relative. So the negative 16 is lower than the points on the left or right of 8. And the 0 is lower than, no, relative max, -16 is higher than the points on left or right of 8, and the relative min of 0 is lower than the points left or the right of 0.